This question is a year one trig question. If I write this out, but replace tan x with sin x over cos x, we will get this. Then let's multiply everything by cos x, so we'll get 3 sin squared x minus cos squared x plus cos x equals 0. And we can replace sin squared with 1 minus cos squared. Remember, we want to get everything in terms of cos x. So 3 minus 3 cos x squared minus cos squared plus cos x equals 0. If we move everything to the right hand side, so this would give us minus 4 cos squared. So if you put everything on the right hand side, we will get 4 cos squared x minus cos x minus 3. If we solve this quadratic equation in cos x on your calculators, just using the equation solver, you should get that the two solutions of 4. The two solutions are 1 and minus 3/4. So cos x equals 1 and cos x equals minus 3/4. We now need to solve those two equations. If we just do inverse cos, make sure your calculator is in radians. There's a pi in the question there, so we know we need to be in radians. If we do inverse cos of 1, we're going to get x equals 0. If we do inverse cos of minus 3/4, we will get 2.42 to 3 significant figures, and we won't get any more values in the range. If we think about the cast diagram, so cos is negative here and here, and 2.42 radians would be over here. Now pi radians would be, this is pi over 2, this is pi. So this solution down here in this quadrant, this would be over pi. So the only solutions we want are 2.42 and 0. For part 2, if we compare the two equations, the equations in part 1 and part 2, this is exactly the same as this. It's just all the x's in part 1 have been replaced with a 2x. So we can use these answers to part 1, and just instead of having an x here, we can replace these with a 2x. So let's just clear up a bit. In part 1, we found out that cos x equaled 1, or cos x equaled minus 3/4 once we'd solved our quadratic, and the range was x between pi and 0. So in question 2, everything is exactly the same. It's just at this time we want to replace all the x's with a 2x. So everything will be the same. It's just we will have 2x equal, because 2x equals 1, and cos 2x equals minus 3/4. We have to replace this with a 2x as well. So our range for 2x will be between 2 pi and 0. Now, if we do inverse cos here, we're going to get 2x equals 0. Now, if you think about the cos graph, where else is the cos graph equal to 0? Well, cos graph looks like this. It's 0. Sorry, where else does cos graph equal 1? Well, it equals 1 here, and it also equals 1 over here, which will be at 2 pi. This is pi here, and 2 pi is over here. So it will be 2 pi. It will also be at 4 pi, 6 pi, and so on. But remember, our range is up to 2 pi. We don't care about anything after 2 pi. So 2x will equal this, and then remember, only at the very end do you divide by 2. So 0 divided by 2 is 0, and 2 pi divided by 2 is pi. We need to do exactly the same over here. So if we do inverse cos of minus 3/4, we will get 2x equals 2.42, like we got last time. I like to do a cast diagram for these. So my cast diagram looks like this. You can see that cos is negative here, so we're going to end up with lines in this quadrant and this quadrant. 2.42, this is pi over 2, this is pi, this is 3 pi over 2, and this would be 0 or 2 pi. So 2.42 will be over in this quadrant. So let's mark in this angle here as 2.42. We're going to need to reflect that down here because we know it's going to be in this quadrant here. So this would also be 2.42, and we're interested in the range between 0 and 2 pi. So we've already got 2.42 here. We carry on going round. That value there will be 2 pi minus 2.42. So if we do 2 pi minus 2.42, that will give us a value of 3.86. And there aren't any more solutions between 0 and 2 pi. So now right at the very end, we divide everything by 2. So we're going to divide that by 2, which is going to give us 1.21. And we're going to divide 3.86 by 2, which is going to give us 1.93. So we have 4 solutions to this, and the 4 solutions are 0, pi, 1.21, and 1.93, all in radians.